Welcome, folks, to this winter special vlog podcast from TechLight. We are bringing this session to you from picturesque co-working space in central Bangalore. The guest for today is Prithvi, founder of Appiko. Welcome, Prithvi.
Thank you.
And the topic for today, in line with Appiko's products, is low power IoT design. So let's quickly dive into understanding what Appiko does in the low power IoT space. Prithvi, can you give us an example of some of your products, specifically in the low power wheel?
So what we do is we develop technology for wildlife conservation. So all of our products are to be used in the field where there's no access to the main power supply. So be it camera traps, animal collars, or animal early warning systems, all of them need to operate for weeks or months together. So low power circuit design and firmware design is really important for our products.
Interesting. So, Prithvi, other than the space Appiko is in, which is into wildlife, what are other use cases where you will find the need for low power design? Can you give us some examples there?
So even a lot of low power design is used in the wearable space, wherein you have the accessory market, which is you have a wearable device and an app working together. This needs a lot of low power design. Then there's the industrial applications where there's deploy and forget concept, where you deploy many sensors like air quality monitoring sensors, and you just forget about it, and it keeps giving you data for years together.
Cool. Anything in the medical space, Prithvi, in terms of low power design? Do we see any products coming in there?
There can be products like the pacemakers, which need to operate reliably without failure for many like months together, so that once it's installed in the body, it needs to work reliably for for a long time.
Right. So, essentially, low power in terms of the time duration for which a system lasts, it can go from few weeks right up to few months or maybe even years.
Years
In
together,
a
yeah.
sense. Right. Interesting. So, from a strategy perspective, when somebody is designing low power systems, what are some key strategies to adopt?
So any of the systems that you described, there is always usually a microcontroller at the heart controlling the various systems. So this microcontroller needs to sleep as much as possible. For other components in the system, you need to put them in low power mode when they're not operational, and if they don't have a low power mode, you have to power gate them so that they the power is cut to them. Then there is usage of strategies wherein the microcontroller which is sleeping reacts to events from the various components. So it doesn't poll and ask for a particular circumstance, but it is woken up by the other peripherals and additional circuitry based on the required events. Then also the core microcontroller needs to outsource as much as possible to the peripherals in the microcontroller as well as to the external circuitry, so that it only wakes up in the desired events. So these are some of the strategies that one can use to make low power designs.
Interesting. So, well, you spoke about some of these components which help in having the low power design and assisting the core microcontroller. What does a typical architecture look like? In terms of what are these external components which are taking load off the microcontroller and handling some of the functionality? Can you give us how a typical architecture kind of looks like?
Sure. So like let's take a typical sensing application. There can be sensors present. So some sensors have a low power mode present in them, like accelerometers, which can take an acceleration at whatever frequency and be in low power mode otherwise. Then there can be sensors like a light dependent resistor, which is just a resistor and doesn't have any low power mode as such, right? So you just don't power it on, only power it on when you need the ambient light value. So there's the sensing component. Then there's the microcontroller which acquires the data. It needs to sleep and be woken up by the low power timers, usually are the RTCs. They can run like for even less than a microamp at times and wake up only at the desired frequency to gather the data, and then there is usually wireless component, because these low power devices are small and all over the place, and wiring is not a possibility. So you have these wireless components that transmit the data only when sufficient amount of data is acquired. So this is like a usual architecture of such systems.
Right. Okay. So, uh, and we got a sense of low power, strategies, design, and architecture. In addition to just being, a low power, which in itself is quite a big deal. What are other advantages that one can get when one designs a low power system?
So like you mentioned, like increasing the battery life is like the prime obvious advantage of making a low power system. The other advantages that a system architect has when they can optimize the system to be low power is, you can optimize the battery size to become smaller. So if you desired battery life is 1 day, you don't need a big battery, right? You can just reduce the system size to optimize the cost and size of the system, as well as when you have some components which has some thermal constraints, like say you have a very high power flash, right? If you can duty cycle it and make it low power, you can get away with smaller heat sinks and smaller system size, um, thus again reducing size and cost.
Right. So, interesting perspective, Prithvi, in terms of not just having the low power advantage, but also in terms of size and heat sinks and so on. Thanks for giving us that wonderful insight. And to end this, just wanted to get some tips on for viewers who are looking at making their own low power design, and wanting to get this manufactured. Any recommendations that you have?
So we routinely use LionCircuits for both PCB manufacturing and rapid prototyping and assembly. We are a one line member, so we would recommend using their service for
Right.
rapid prototyping.
Well, thanks.
Thank you.
Thanks, Prithvi. So that's it from our side in this low power IoT design winter special edition of TechLight. Thanks a lot, Prithvi.
Happy to be here.
Yeah.